Okay, in this video, we will apply what we learned to solve a practical problem. The problem we are going to solve here is called mixture problem. Okay, let's consider a problem of a tank. This tank originally considered 300 gallons of solution. Okay? And at the beginning, there's 50 pounds of salt in the tank. Then there's a solution get in with a rate of 3 gallons per minute. Okay. This solution, the concentration for the solution to pump into the tank is 2 pounds per gallon. Okay. Then the solution pumped in and mixed with the solution in the tank. Make them well mixed, then pump it out at 3 gallons per minute. Okay, here's a question. So we want to know at a given time how many pounds of salt in the tank. Okay. So we use Q to denote such a quantity. Okay, Q here. So Q here is the amount of salt in the tank at the time t. Okay. So obviously, the number of pounds of salt in the tank is a function of t. At a different time, the Q will be different. Okay. What we're looking for is the relationship of Q and t. Let me say that again. Q here is the number of pounds of salt in the tank at a given time t. So we want to find such a relationship between Q and T. So in order to do that, we need to find an equation Q satisfied. Okay. So as we know, the number of pounds of salt is a function of time. So it's changing. Okay. So rate of change of number of pounds of salt in the tank, dQ dt, is equal to rate of substance in subtract rate of substance out. Okay. So this equation, just like it's our common sense. Okay. So if the substance get in faster than the substance get out, then dQ dt will be positive. It's increase. The Q will be increasing function. Okay. Now for this problem, so in order we need to find out for this specific, we need to set up the equation, okay, for this specific problem. So we need to find, first of all, let's find the rate in, okay, let's make it short, rate in, which means how many pounds of salt get in per minute, okay. So we know, okay, we have like 3 gallons per minute. That's not the number of pounds of salt get in. That's how fast the liquid get in. Okay. So we have like 3 gallons per minute get in. And we know 1 gallon, there's 2 pounds of salt get in. So times 2 pounds per gallon. Okay. That will give you equal to 6 pounds per minute. Okay. So we know how fast the number of pounds of salt get in. It's like 6 pounds per minute. Okay. So the solution get in for the substance rate is like 6 pounds per minute. Okay. Now to find rate out, which is a little bit harder than the rate in, we need to find how fast the liquid get out, and also we need to know the concentration of the liquid get out. Okay, the concentration for the liquid get out is like the same concentration in the tank. Okay, so the concentration is the total number of pounds of salt at time t divided by total gallon of solution. Okay. So what is the total number of salt in the tank at a given t? That's exactly our Q. Okay. we don't know. We use Q to denote our unknown. So total number of salt in the tank at the moment T divided by total gallon of liquid at T. Okay. So originally we have 300 gallon in the tank. Then the solution get in with 3 gallon per minute and the same rate get out. So the 300 gallon for any time T is always that. Okay. So at given time T, the number of gallon is always the same as 300 because the solution get in and the solution get out with the same rate. Okay. So this is the concentration. Okay. So rate out is equal to 3 gallon per minute. That's how fast solution get out. Then in 1 gallon, we have like Q divided by 100. This is pounds per gallon. Okay, so we have both things. Okay, that is equal to 300, sorry. So you multiply those things, you got Q over 100. This number pounds, how many pounds of salt get out per minute? Okay. So finally we have like dQ dt is equal to rate in, which is 6, minus rate out, which is Q over 100. Okay, so we got a differential equation, and also we know the initial condition. At t equal to 0, that means at the beginning, how many pounds of salt in the tank? We've been told is 50. Okay. So we got a differential equation with the initial condition. Okay. Now we want to solve this differential equation, find the Q. Okay, now the next question, do we know how to solve this equation? Okay. Yes, we do. Okay, so this equation is a linear equation. Okay. You can write like this way, plus 1 over 100 Q equal to 6. Okay. So with a piece of T equal to 100 and G's of T equal to 6. Okay. So now we can use our formula to solve this linear equation. Okay. So our mu here, remember, is e to the pt dt. So for this case, is e to the 100 dt. No, 1 over 100, sorry. So therefore is e to the t over 100. Okay. Then we can find the q. Okay. Q's of t there is equal to 1 over e to the t over 100 times the integral g. G is 6. 6 times mu. Mu there is e to the t over 100 dt plus c. Okay. So you integrate this, we find the q's of t here is equal to, just integrate that, you got 600 plus c e to the negative t over 100. Okay. All right. Then we know at the beginning t equal to 0, q equal to 50. Okay. So therefore we got a 600. Let t equal to 0, c e to the 0 give you 1. Okay. Therefore c here is minus 550. Okay. So finally we find this. Q's of t is equal to 600 minus 550 and the e to the t over negative t over 100. Okay, now we're able to answer the question. Okay. For example, after 2 seconds, how many pounds of salt in the tank? what do you need to do? Just replace t by 2. Okay. And when t go to infinity, okay. When t go to infinity, e to the negative t over 100 will go to 0. Okay. Then q of t will goes to 600, which makes sense. Okay. Think about that. The 2 pounds per gallon solution get in. So after a long time, so the concentration in the tank will be like 2 pounds per gallon. Multiplied by 300, give you 600 number of pounds of salt. Okay. Now let's change the problem a little bit. It's a little bit more complicated. Okay. We consider same problem. Okay. Same mixture problem. Again, same setting. At the beginning, there's 300 gallon of solution there, and with 50 pounds of salt at the beginning. Okay, same solution got in with same rate, with 3 gallon per minute. Okay, and 2 pounds per gallon. Okay. Now we change here. We change the rate get out. In the previous problem, we have like 3 gallon per minute get out. Now we make it a little bit slower. So say 2 gallon per minute. The solution get out with 2 gallon per minute. Okay. Now we want to answer the same question. We want to find the Q's of T. Okay. Again, what is the Q's of T? Q here is the number of pounds of salt in the tank at the moment T. Okay. So we're going to use same formula, right? dQ dt is equal to rate of substance in. I'm writing short. And the rate of substance out. Okay. So the rate in will be same. Right? The rate in is now changed. It's like 3 times 2. Give you 6 pounds per minute. Okay. Which means that the rate of substance get in is 6 pounds per minute. Okay. Now the mix with the solution in the tank, then get out. Okay. With the solution get out with 2 gallon per minute. Okay. So to find the rate out, again, we need to know the concentration of the solution get out. Okay. So the concentration is total number of pounds of salt in the tank divided by total gallon of liquid. Okay. In the previous case, the total number of gallon in the tank is always 300. Okay. Now this problem is different because we have 3 gallon per minute solution get in and 2 gallon get out. Okay. So first of all, we need to figure out at a given time how many gallon of liquid in the tank. Okay. So let's figure that out. At t equals 0, the number gallon of solution is 300, right? Okay. When t equal to 1. So how many gallon of liquid? In 1 minute, 3 gallon get in, 2 gallon get out. So at the t equal to 1. So the number of gallon of solution is 300 plus 1, right? Then t equal to 2. How many gallon of solution in the tank? Will be like, after 1 minute, 1 gallon more, then 2 gallon more, right? So at any given time equal to t, how many gallon of solution will be like 300 plus t, right? Okay, so the concentration for the solution pumped out should be total number of salt at the moment t, which we know is the Q's of t. Okay, we don't know what it is, but we know we denote by Q. Then over total gallon of solution, which is 300 plus T. Okay. At any given moment T, this is our concentration. Okay. This is our concentration. So the rate out should be 3 with 2. I mean, 2 gallon per minute times your concentration, which is Q over 300 plus T. Okay. Okay, now we can write our differential equation. dQ dt is equal to rate in, which is 6, subtract rate out, which is 2Q over 300 plus T. Okay, again, we know the initial condition. At the beginning, there's 50 pounds of salt in the tank. Okay. So, if we solve this differential equation, we can find the Q, which is the number of pounds of salt in the tank. Okay. So, do we know how to solve this equation? Again, we do know how to solve it. This equation is linear. Okay. So, you can write like this. 300 plus T times Q equal to 6. So this time piece of T here is equal to 2 over 300 plus T. And the G's of T here equal to 6. Okay. And you solve this equation, use our formula, you're going to find Q's of T like this. I'm not going to solve it. Okay. 600. The goal of this section is how to modeling. How do we do the modeling? Minus 4.95 times 10 to the 7, then 300 plus T to the negative 2. Okay. So, then we solve this problem completely. You give me T, I tell you Q. Q is the number of pounds of salt in the tank at a given moment T.